Hi everyone, welcome to my channel Pymedaca. I believe that you all know about the intent of Pymedaca. However, it's my responsibility to reinstate what is Pymedaca is about. You can read from here. Pymedaca is a piping academy to learn about piping design engineering. It is as simple as that actually. But one of the core value of Pymedaca is to educate and teach you the actual job requirement, because there has been an immense difference between what has been taught in the institutes and what is actually required for the real-time job. So once you understand the requirement of a real-time job, you will be able to perform much better than before. So with that intent, I am making videos in order to guide you, in order to help you to understand what is actually required for a real-time job. So by this way, you will be able to change your mindset. You'll be able to educate better than before. Actually, you will be able to prepare yourself in order to clear the interviews far better. So this video is basically about the part 3 of my previous videos. The previous videos, you can refer the part 1 and part 2, where we have discussed about the piping design sample projects. So which have started from part 1. I can show you over here, but this video is all about the stage 3 and stage 4 actually. So for those who wanted to understand about the previous project, let's recap the design scope what we have discussed. See, the design scopes in this piping projects we were discussing was, the first one is skid location. This is covered in the part 1 video. And the second one, piping routing, where we have immensely and we have detailed discussions done in this video, which is covered in the part 2. And the tie-in location and pipe supports. And in this video, I'm specifically going to cover the tie-in locations and pipe supports by with this video, and this project will be completed. So you can use this experience in order to clarify your doubts and in order to understand how piping design is actually followed in the real-time job. So for those who haven't watched my previous video, you can go and watch over here, which is very useful to understand how the piping projects from the grassroots level it has started, and what are the areas that we have to do as a design engineers actually. So it's very interesting too. You can refer the part 1 videos, and there are part 2 videos where we have immensely discussed about the making of pipe routing and how decisions are made in order to optimize the designs basically. So this video we are going to go for the part 3. So let's get into the part 3. So part 3 is basically about the final design. So we are going to conclude the design actually. So there are two things that we are going to discuss in the part 3, which is tie-in location and pipe supports. So without wasting your time, let's get started. So the first one is going to be stage 3. I'm going to cover the stage 3 and stage 4 in this video. So by this we are going to complete the project. So what is stage 3? Stage 3 is about tie-in location. So tie-in location has to be finalized. In the previous videos, we have seen the skid locations and as well as pipe routing. But now we are going to see the tie-in locations finalization. But before that, we have to understand what is tie-in location is all about. Okay, the tie-in location, it's nothing but the definition of tie-in you have to understand. So what is tie-in basically? It's as simple as that. A connecting point with an existing piping. For example, if there is an existing piping and you're going to take some tapping, so that tapping is a tie-in point. Okay, the tie-in point either be 1 or it may be 2. Basically, the tie-in point is a connection between your new piping and an existing piping. And we can add one more point over here. The tie-in point is a point where we refer the cutting point basically. So if you are going to cut the existing piping in order to take a new connection, you will be able to you have to identify those cut points. Those cut points are the point where you're going to connect the new piping. So those are tie-in points. In a simple term, we can make it in this way: a connecting point with an existing piping. Okay, so it's just a layman understanding basically. So piping is all about basically your common sense. So let's get into the subject. Okay, so this is what we have finalized in our previous part 2 while finalizing the pipe routing. We have taken the line over here and we have connected the line to the 2-inch available spare nozzle. So there is no cutting in the existing piping. We found some spare nozzles available in the header, so we directly used it. So all you have to do is that existing blind over the spare nozzle needs to be removed and new piping needs to be connected. So for those who wanted to understand about the spare nozzle is nothing but there was a nozzle, there was a flange provision already available in the header, which was set at the beginning of installation of this 8-inch line as a for a future purpose. So generally in piping we used to provide a lot of future purpose branches, so that one need not have to cut the pipe all the time. If you had already provided some connections for the futures, identifying that this requirements much earlier, then you will be able to use that tie-in actually. Otherwise what happens, remember, if we don't have this 2-inch line, then what I have to do in order to provide this 2-inch connection, I have to tap the header, right? So basically I have to do some welding actually. So welding is actually a costliest job. So basically if you're going to disturb the existing header, you need to have a lot of precautions basically. So that's why the spare nozzles are provided. So we have finalized this in the previous routing. For those who do not have not able to understand what I'm discussing, you have to go to my previous videos to understand how this routing has been finalized. Fine. So this was discussed in my previous video. We have finalized this routing, right? So now let's see how this looks in the plan. So in the plan view, it looks like this, right? The line comes from here. This is the skid we placed, and from here, and it goes up to the rack, and from here it again raised and dropped over here to connect to the existing 2-inch flange connection. So this 2-inch flange connection was a spare nozzle available in the existing 8-inch header. Okay, so we don't have to do any welding over here, just going to be the flange connection over here. So this is what finalized. Now we have to identify how the tie-in point needs to be fixed actually. So let's go to this elevation view itself, because this is where we have finalized, right? So what are we doing? We are going to connect this new line. New line is the dark blue line. Fine. The new line into the existing header where you already have 2-inch. So this is the 2-inch flange available. From here I'm going to connect my the new 2-inch line. So this is the exact point where my new piping and old piping is being connected, right? See, this line is the old piping, okay, and this line is the new piping, correct? So this new line is connecting to the existing piping with the flange, and this flange is over here. So this is the tie-in point for me. So for me, this is a tie-in point. So in this scope, we only have one joint where the line is connected to the existing line is only at one location. So that's why the tie-in point is 0, 1 actually. If there are multiple connections, then you have to give multiple tie-in numbers. The tie-in numbers, generally it starts from 0 or 0, 1 and it goes to 0 to not 0 basically. So it starts from 1 and then it continues on as long as you have the number of tie-ins which is required for the project, okay. Now let's go to the plan. So in plan, this is where the line is connected, and this joint number is known as tie-in number actually, and this is referred as tie-in 01. And this tie-in number you have to indicate in the P&ID as well actually. So being a piping engineer, you have to give this information to the process engineer, because process engineer may not be able to understand whether it's a flange joints or whatever it is actually. So ensure that the line is shown in the P&ID is matching with your field conduction, so that what happens in future if somebody refers it and they will be able to understand that this is where from it has been taken, right? So this is what the tie-in number is about. For the education purpose, I'm going to discuss about another example. Say for an example, if not the spare nozzle, okay, if the remember there is no spare nozzle, then what you have to do? You have to connect this line in the existing piping itself. So in order to do a connection in the existing piping, you have to make a T, right? Because this is 8-inch header. Your new line is 2-inch, right? So from 8-inch to 2-inch, you have to do a T connection, right? So it could be as per your piping metal specifications. Sometimes it could be a reducer T. Sometimes you have to reduce it with 8-inch to 4-inch T, and then you have to provide a reducer. So that combination would be different, but ultimately here the intention is to logically understand what is tie-in point is. So if you are going to connect the new piping in the existing header, like where you do not have a spare nozzle. So the scenario is, earlier case you had a spare nozzle over here, you have directly connected, but if you don't have a spare nozzle, where you will connect, you have to connect in somewhere in the piping. So to connect somewhere in the piping, you have to provide a T connection. If the T connection comes, then there will be two cutting points, right? Because the T has to be installed, right? So the portion of the T to be installed needs to be removed from the existing piping. Then the T will be placed. So there will be two cutting points. So tie-in number 1 and tie-in number 2. So if there are multiple lines, say for an example, if your line there is another branch from here goes to somewhere else, actually that will be tie-in number 3. So tie-in is nothing but a point where your new lines are connected to the existing line. So it's far better to make the tie-in numbers in a sequence so that you will be able to understand the order of line connections. Understand? Okay. Now let's go to the stage 4. So so far we have discussed about the tie-in point. Okay. So tie-in point has been finalized. So now we have to go to the next stage, what is pipe support, which is one of the critical area in piping design, because if your support fails, then the entire piping system fails. So let's get into it. The first stage is that you have to identify how many number of supports you have to provide. So this study is about how many number of supports that you have to provide. Let's get started. So this is the plan view we have set as a final, right? So the line is going and connecting to the 2-inch spare nozzle. Now here I wanted to fix the number of supports first actually. So before getting into the support finalization or fixing, you have to understand how the entire scheme is basically. See, this is an equipment we placed, and from here we have taken a line, and the line is raised over here, and from here this elevation is different. Okay, so this elevation is lower, this elevation is higher. So from here the line is raised, and then it went on over the pipe rack, and from here again it raised, and then here it dropped. Okay, so this is the entire chemistry of the line. Okay, so here one thing you have to understand, wherever there is an equipment and you're taking a line from the equipment, the foremost thing that you have to keep in mind is that you should not put any extra load to this equipment nozzle, because if you're going to put an extra nozzle to this equipment nozzle, the equipment will fail. Replacing an equipment is much costlier than replacing any piece of pipe. Okay, so the first and foremost thing that you have to do is that provide a support near to this equipment nozzle, because here you can see a valve over here. The valve itself has a weight, so immediately you have to support it actually. So as near as possible. So it doesn't mean that you have to provide below the nozzle itself. You have to keep it a little more away, because the nozzle will have some tendency, will have some capacity to withstand. But however, ideally what you have to do is that you have to provide a support near to the nozzle. This is first step. Second step is that you have to check with the vendor of this equipment supplier how much load this will take. Okay, and if you have these two informations, once you provide a support here and then parallelly check the loads capacity of this particular nozzle, then accordingly you can check with your stress engineer. Generally for the lines which has a temperature less than 100 degrees Celsius will not have such issues. You just have to provide as near as possible. But for lines which are above 100 degrees Celsius, you have to take this action very cautiously. Okay, so logically what you have to do, you have to provide a support which is as near as possible. Understand? Now let's go to the next one. So next support we are placing it over here. This is actually a natural support. Here you have a pipe rack. So instead of placing the line which is directly on the pipe rack, you have to put some support over here. These supports are generally be shoe supports, because when you're placing a pipe directly over the pipe rack, if the pipe is tend to move, your pipe will have an rubbing tendency with over the pipe rack. So that will take off some material. So there will be tear below the pipe if it is not provided with a shoe support. If you are providing a shoe support, then the shoe is going to slide over the pipe rock, so that you don't have to worry about the failure of the piping, right? So generally we call this as a rest support. So for those who wanted to understand about the types of support and how to provide the types of supports, you have to go and refer one of my best courses which are already available in my website. So I will give the link in the description box of this video. You will be able to find the description of that particular course. So that course will define you how to choose a support, what type of supports, where to be used, what is the purpose of using different types of supports, and all dynamics of the pipe support installation basically. Okay, so let's move on. Then I'll have to provide another support over here, then I'll have to provide another support. So far we have provided 1, 2, 3 and 4. Okay, here I wanted to say one more thing. Actually, I have to provide one more support over here. Why I have to provide one more support over here? See, if you look at it, the entire span over here, it's a little more higher, right? So generally, if there are more span which is not supported, there will be a sagging over here, because this line from here, it's coming straight and rising up and going over here. So this much of weight will be sagged. So basically this portion will be sagging more. So in order to support this line, I'm not going to provide a support here. I have to provide a support here. That is because if I provide a support here, the line will expand during the expansion stage. So if the line is expanding in the vertical point, then there will this portion of support will not get rested. So basically, in order to give this flexibility, so we have to provide a support over here. See, if this connection, I mean this length, I can say not this length, this length basically. If this length is shorter, then you don't have to provide this support. Shorter means how much? If this length is lesser than 1.5 meter, then you don't have to worry about this support actually. But if this length is more than 1.5 meter, then be cautious about the sagging part actually. Okay, so I'm going to provide a support over here for a safer side. This is going to be a rest support. Okay, so basically how many number of supports we have provided? 1, 2, 3, 4, 5. Okay, so the first 4 supports we placed comfortably in order to ensure the line is safe, and the 4th support we have placed in order to ensure that there is no sagging after further evaluation. Now let's go to the next actually. The next is, now we have to determine the types of supports. See, in the previous slide, what we have decided, we have finalized the number of supports. Now we have to finalize the types of supports, because types of supports determines how the dynamics of the piping is going to perform during the real-time operation. Let's get into the subject. So in order to provide a type of support, you have to analyze the pipe movement. So without analyzing the pipe movement, you cannot provide a defined type of supports. Let's get into it actually. So one of the primary factor for analyzing the pipe movement is the temperature. So let's consider the temperature of this line is 85 degrees Celsius. So at 85 degrees Celsius, what will be the pipe movement? That as a piping design engineer, you have to aware about it. You have to understand that the pipe will expand even at 1 degree, okay, even at 2 degree, and 3 degree. So for this, you don't have to remember something which is logically, we already have some data which is populated in ASME B31.3. This is what it is, Appendix C. Go to Appendix C. Appendix C will clearly tell you how much length the line will expand. So in order to educate you, let me just give a brief about it. Appendix C. Here, 2 things you have to understand. So if you look at this table, so here the temperature range 20 degrees Celsius to minus 100. I mean this is minus all our temperatures basically, minus 200, minus 100, minus 50 and 20, 50. So up to 275 degrees Celsius you have. So basically you have this temperature range over here. And here we have 2 things. A is mean coefficient of thermal expansion. This is not required for us now. We are only concerned about the B. B is linear thermal expansion. How much length the pipe will expand. So what is our piping? Okay, let's consider our piping is a carbon steel piping. Fine. So in order for a carbon steel piping, so we are have to find what is the expansion based on our temperature. So what is our temperature? Is 85 degrees Celsius. So somewhere between 75 to 100 degrees Celsius, right? Roughly. You don't have to be accurate, because this is not a critical line, but at least you have to understand. So from 75, for 75 degrees Celsius, the line expands 0.7 mm. Okay, 0.7 mm per meter. So you have to understand this is per meter. So if you have a 10 meter of a piping, then the line will expand 7 mm. You understand, 7 mm is too big. right? So if the line is going to expand 7 mm, so it is whatever that comes in front of the 7 mm, it will break through basically. So at 85 degrees Celsius, we can consider it is 0.8 mm or 0.85 mm. So basically, if the line length is 10 meter, then it will expand around 8.5 mm, 8 mm to 8.5 mm we can consider. So ideally, the purpose of showing this is that any material will tend to expand, tend to increase its length during the thermal condition. Thermal condition is at expansion condition for any temperature range. Even for the 50 degrees Celsius, the line is expanding. Only in 20 degrees Celsius, there is no expansion. See, theoretically, there is no expansion because that expansion is much lesser. So that's why it is not recommended, right? So, but you have to understand as a mechanical engineer that as a material, all the material expands even at 1 degree or 2 degree. If there is a difference in temperature, it expands basically. But if the expansion is much negligible, then we will consider it as 0. So here we can consider that somewhere around 8 mm it will expand for 10 meters, right? Okay, so let's get into the subject. Okay, so this is our final layout. Okay, let's analyze the layout first. So from here the line start. So you have to imagine that the line is 85 degrees Celsius. Okay, at 85 degrees Celsius, let me take my pen actually. At 85 degrees Celsius, so the equipment point is fixed. So this point is not going to move actually. So the equipment is a bigger unit, so it has more weight. It is anchored and fixed actually. So if the line needs to expand, it only needs to expand in this direction. So this direction, I will mark it over here. Okay, from this direction. If the line is going to expand in this direction, then this length will be extended up to here, right? It will extend it up to here. Then what about this length? If this line needs to expand, it has to expand in this way, because here you cannot expand actually. But still, this length will have some flexibility, so it will give some backward reaction as well. But however, logically, the line has to expand over here actually. Okay, so this is logical understanding. So eventually what happens actually, you see these expansion and these expansion both are going to do simultaneously. So simultaneous expansion will not keep the line linear, so it will tend to move actually. So in reality, during any expansion, the line will move like this. Say for example, this line will tend to move like this, and this line, because this, if this moves over here, this elbow also moves over here, right? And this will also move like this. Okay, and finally it will go and connect over here, because here there is no possibility for a movement. It is neck to neck, immediately connected, right? So this is the movement it is going to give you. So basically this will be somewhere around 5 to 6 mm or 8 mm, and this will be 5 to 6 mm or 8 mm. So I'm not discussing with an accurate point of view, but logically you have to understand at 85 degrees Celsius, there are straight lines will try to move away from its original position in order to support the thermal expansion. So the thermal expansion, since it is connected actually, it will deviate from its original point and move like this. Okay, so now let's go back to our subject. Let's remove this. Okay, now let's go back to our theory. Okay, so this is how it is actually. So now we have to understand how to put the support actually. So we know we understood how the line movement is. So first foremost, I am going to place some whatever supports that I have already found actually. So there were 5 supports, right? Now I am going to determine the type of supports. So here it's going to be rest. Why it is rest? See, for again repeatedly I am telling you, for those who wanted to understand about the types of supports available, where it is used and how it is used, the dynamics of providing this pipe support design, you can refer in my course. My course is available in my website pymedaca.com, and you can go to the course tab, where you will be finding 3 best courses available, which is useful for those who wanted to understand about the actual job requirement. Okay, so that course will give you idea about it. So there are different types of support. Rest support is the one which is going to support from the bottom of piping. Understand? Now why I am going to provide rest support over here, because here I don't want to stop the movement. Why I want to provide a rest support over here, because this point is already anchored. So the equipment is anchored. I don't find any sideways movement over here. Here the only movement is that it needs to support the nozzle loading basically. So I have to provide a rest support over here. Now let's go to the another support, this support I'm going to provide a rest with a guide. Why I wanted to provide a rest with a guide? Because since this line is expanding this way, so if I don't provide a guide over here, the line will tend to buckle more actually. So if I provide a guide over here, it will tend to remain within the same position. So imagine if there is any nearby line, so if I don't provide this guide support, this line will hit over here. So I'm restricting the movement of the piping by providing guides. Now what is next? Next is rest. See, if you have continuous racks, you should not be providing rest with guide continuously. Every alternative rack should have the guides basically. So here, so this is a guide, and here we left only with rest, then the next one is a guide. So this is an alternative, so one after other. Okay, so this is how the guides are generally followed, because if you provide a guide over here and guide over here, then anyway the line is going to be in a straight line, right? You don't have to provide a guide over here. So that's much logical basically. So this is how the supports are provided. So, and over here, as I said, this support I have been providing to avoid sagging. So the sagging, in order to provide the sagging, the only rest support is the one that is going to take care of it, right? So because rest support from bottom will avoid the sagging basically. So this is how we have to determine the supports. So basically in piping design engineering, you have to analyze many aspects of the piping design. Why it is required, what it is, what it makes, and how it will be constructed, what is the real purpose of it, how it will expand, if it expands, and what type of support you have to provide. So all these factors needs to be analyzed, and only then you have to give a solutions actually. That's why I always felt piping design engineering is one of the most fantastic field where it utilizes the full ability of the mechanical engineer. So with this, I'm just going to conclude what we have discussed and studied in this piping project. So the scope of the design was to finalize the skid location that we have studied in the part 1, and pipe routing in part 2 we have covered, and tie-in location and pipe support location we have covered in this video. So hope this piping project will help you to understand how the actual design being performed in the actual job. Okay, so with this, let me tell you that we have completed the project. So please use this project knowledge and try to enhance your piping design knowledge. If you have any queries, you can always post a comment over here. I'll be able to respond you for your queries. And thank you so much for watching my videos. And please kindly request you to share this video to many people who are interested to learn about the piping design. And also don't forget to subscribe to my channel.